Hello bachcho, let's read the question. So the question says, a beam of light that consists of a mixture of red, green and violet light strikes a prism surrounded by air as shown. This is shown. Indices of refraction for this prism for various colors are indicated in the table. This is the given table. An observer is located to the right of the prism as shown, which physical phenomenon is illustrated by the fact that the observer will not see all the three colors of light. We are given with four options, which are four physical phenomena, out of which one correctly describes the situation given in the question. So let us first revise the key concept behind this question. So what are the key concepts? So the first key concept behind this question is basic knowledge of natural phenomena. Like Doppler effect, diffraction, dispersion and total internal reflections, which are given in the question. And second is condition for total internal reflection. What is the condition for total internal reflection? We have sin alpha is equal to mu2 upon mu1, where alpha is the critical angle and the incident angle theta must be greater than alpha, which is critical angle. So this is the condition for total internal reflection. And the second condition is that the ray must be moving from denser medium to rarer medium. So these are two conditions for total internal reflections which we must know to solve this question. So let us check each of the natural phenomena one by one. So what is Doppler effect? Doppler effect. It is the change in frequency of wave when the observer, or we can say that apparent change in frequency of wave when the observer is moving relative to the source. So in this question, this fact does not describe the given situation, hence Doppler effect is not the reason. Now second, we have diffraction. Second option is diffraction. So let us check what is diffraction. Diffraction is bending of waves around small particles which creates secondary sources. It also does not describes the phenomenon taking place in this question. Hence option B is also wrong. Diffraction is not the phenomena behind this. Let's study dispersion now. What is dispersion? Dispersion is the breaking of light into its breaking of light into its constituents due to refraction and Snell's law. This somewhere describes the situation but does not describes it completely, because uh, something more is being applied here. So option C is also wrong. Hence the correct option is D. Let us check what is total internal reflection. Total internal reflection says that whenever the light travels from a denser medium to a rarer medium, let's say this is denser medium, this is rare medium, and light makes a certain incident angle which is theta, which is greater than critical angle, then it internally reflects from the boundary of these two mediums. This phenomenon is known as total internal reflection. For this to happen, we have defined sine alpha is equal to mu2 over mu1. Now, in this case, what is going on? We have alpha r is equal to sine inverse of 1 upon 1.43. Similarly, we have alpha g, which is critical angle for green color. It must be equal to sine inverse 1 upon 1.4. Similarly, alpha yellow is equal to sine inverse of 1.37. From here, we can conclude that further calculation, we get alpha r is equal to 43 point something, which is less than 45 degree, because in this case the incident angle is given to us as 45 degree. Here incident angle is greater than alpha critical angle, hence the red color internally reflects. Thus the total internal reflection correctly describes that the observer will not see all the three colors of light. Hence the option D is correct option to this solution, which is total internal reflection. I hope you understood it well. Thank you.